Hello everyone, I'm going to demonstrate the lab for this week, lab 6, effect of a magnetic field on moving charges. The purpose is to investigate the effect of changing magnetic field on various moving charges. So, if you get this lab description, I will use according to the procedure section 1 and section 2. So let's start from section 1. If you go to Beyond Labs, click Open in Physics. Just take a few seconds, then you will see the lab. So once you get this worksheets, then find the, I think it's this one, electricity and magnetism. So the effect of a magnetic field on the moving charge is at the bottom. So click on that, you will see today's lab setting. So we have this one is electron gun, and this device is the one that generates magnetic. So it's a magnetic field, and the detector is phosphor screen. So we can turn on this screen by click the button here. So now we see this one. Okay. Now we just move the screen and make sure they are parallel. So we'll use this grid. So you take click on grid and you put this grid on the screen. Then we're able to tell how far spark move and in which direction. So now this electron gun is open, or it's turned on. It turns on. Then we see one spot in the center of phosphor screen. So according to this the procedure, we are able to answer the question number 1, 2, 3. So number 1 says, what do you observe when this phosphor screen is turned on, and what do you think it shows? So that's this one. It shows the electron beam on the screen. What happened to the sparked electron gun on the phosphor screen when this magnetic field turned on? So we can turn on this by set at mu t, that's a micro Tesla. So you can see the spark move to the right side. So now it's a 30 mu t, and the spark move from original place to is 1, 2, 3, 4, 3.5 centimeter from the origin. And number 3, what do you think would happen? What do you think would happen in the spark if we increase the voltage of electron leaving the electron guns, and why? So we can try this. Let's increase the voltage So you can see the spark becomes brighter. So then if I decrease this, then you can see the spark becomes weaker. And if I use 1 mu volts, it just disappeared. So then I increase to 100. That's the 1000 mu V. So you can answer this question. That's because of the amount of electron increases, so that make this spark more brighter, bright, make it brighter. Okay, so now we move to schedule section 2. So we already increase, it says this increased voltage of source and clicking. By clicking is 100 place in electron gun voltage controller. So that you're not changing, let's say, not changing the amount of electron, but change the kinetic energy. Let's see what will happen. So now it's this. So if we increase the energy, the kinetic energy, the spark move back to origin. So if I decrease, then you can see it's move away from origin. Oh, that's too much. Okay. So then the next step, with this you can answer question number 4 and 5. So number 4 says, what happened to the spark on the phosphor screen when you change the voltage? Why is that? If we change the volts, the brightness of the spark changes. If we increase the voltage, then the brightness is increased as well. Because this amount of electron increases when we increase the voltage. And then question number 5, what do you think would happen to the spark if increase the strength of the magnetic field that the electron beam is passing through, and why? So let's increase this. I will increase the. Okay, let's increase. See, if we increase the strength of magnetic field, then this spark move further from the origin towards right side. Why? Because there's the magnetic force is greater when we increase the strength of the magnetic field. Okay, so now let's back to the schedule, this procedure section 2. Now we'll change the source of electron. So now let me turn off this. Then put it back to storage stock room and bring the alpha resource here. Then go to lab and bring this one. Now open the lead and open this the phosphor screen. So now if I close this, there's no light. Yeah, there's a light here, and the spot in the center. So then change the unit of the electric field. Now it's a micro Tesla. So let me click this, change to milli Tesla. So it's 1,000 times higher than the micro Tesla. Okay. So now you already see the change in the on this screen. So now, yeah, I changed this and increase the force up to 300. So 1, 2, 3. So you can see the spark move to the left from the origin. Let me turn down the. Okay. So that's a 300. The origin. Yeah, that's. I think orange is here 1, 2, 3, 3.5. So that's the phenomenon we observed. So now we can answer question 6 to 8. So what happened on the phosphor screen when alpha source is used? So this alpha source is used, the spark moved to the left because alpha is a positive charged particle. It's a proton. Then question number 7 asks, which direction the spark move when you increase the magnetic field with alpha source? How does this compare with direction movement for the electron in the magnetic field? So it's opposite to the movement of the electron beam in the magnetic field. So the one we saw before, that's to the right side. But if we use the alpha source, it moves to the left side. So while moving charged particle deflect in magnetic field, so the reason is this the magnetic force. So the moving particle will have the magnetic force on it, so it will change its direction. So a charged particle at rest won't be affected by this magnetic field at all. So why this moving particle affect? Because moving, according to the principle, the moving particle will have this velocity, and with its mass. So the force proportional to mass and velocity squared according to this principle, the formula we learned. So that's the reason. So once a particle is moving, then there's a magnetic force on it. And question number 9, why does this significant stronger magnetic field strength move the beam of alpha particle compared to the beam of this electron? The reason is the particle, alpha particle, is heavier than the electron, so we need to increase the strength of magnetic field to move it. The last question, what technologies or applications of connected between electric and the magnetic field can you think of? Describe the physical process. I think this one, I found that this the example that you can see. This is the example. Electric fan and blower and other cooling system use an electric motor. We know those motors worked on the principle of this electromagnetic induction. So any of this electric appliance, so electrical motor is moving by magnetic field produced by this electric current according to Lorentz force principle. So those motors are very inside and rotating cost based on the application. So that's the principle and the example. Okay, so that's all for today's lab. Thank you. Bye-bye.